Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and greetings. My name is Muhammad ZUNNURRAINIE bin ZULKIFLI and this is the name of my co-researcher and my co-author for this research paper. I'm from Faculty of Electrical Engineering and Technology from University Malaysia Perlis UNIMED. So without further ado, I'm going to go through my presentation today. So the title for my research paper is Acoustic Impulse Response for measuring the firmness and insidious fruit rot of mango. More accurately, is Harumanis mango that was especially bred in the state of Perlis in the northern peninsula of Malaysia. And this is the outline of my presentation for today. I'm going to go through introduction, past research, methodology, research and discussion, conclusion, and on the end of the session, we will do the questionnaire session. Okay, now let's go to the introduction. As we can see in the slide, this is the device that I developed in order to detect the presence of IFR disease inside of Harumanis mango. Okay. For your information, IFR disease is a disease that will cause the internal tissue to break down, as shown in the slide. So the problem that inspired us to develop and to research this device is that there is almost no device that was able to detect the IFR disease. Up until now, the local farmer still use the traditional method to check the presence of IFR inside of the Harumanis mango. This will lead to low accuracy and there will be a human mistake or human error during the checking process. The main objective of this research paper is to develop and create an acoustic impulse response that will be able to measure the firmness and to detect the presence of IFR in the Mangapira indica L and also known as Harumanis mango. And the second objective of this research paper is that the device will be able to investigate the internal properties of the Harumanis mango. As for the past research, there are two major methods that constantly used. The first is impact method and the second is swab sine wave method. So for this research paper, I choose to upgrade the impact method to another level to get a better accuracy, a better result, and more consistent result. So now let's go to the methodology and I will explain about the hardware development for this device. So the microprocessor that I use is Raspberry Pi 4 that I equipped with the touchscreen LCD screen. So why do I use touchscreen? This is for me to create a monitoring system. Okay, so the second reason is that the touchscreen LCD can be accessed easily to configure any error during my troubleshooting sessions. And the last reason why I use this is because it is compatible and easy to command the activation for the hammering mechanism to start. Okay, next is for the hammering mechanism and the measuring for the knocking sound. Okay, so to create the knocking sound, I use linear mini solenoid actuator. Okay, this will be hammered and will be touched to the surface of the fruit and it will create a knocking sound. The actuator force was calibrated to ensure not to deform any of the fruit surface. Okay, when the knocking sound was produced, the mini USB microphone will measure and record all of the frequency and all of the decibel into the microprocessor to process it using the algorithm that I use. This is the adjustable step-down buck converter board. I use this to ensure there are no overflow in the power supply into the Raspberry Pi 4. This will ensure the safety of the sensor that I use, and it will not burn the sensor. Okay, the solid state relay is to ensure the mini solenoid valve does not jam when we press the start button repeatedly. And this is the main power source for this device, that is 12 volt only. And all of the hardware that I tell before is placed inside the PVC electric box. This is to avoid the component from potential hazard such as water and so on. And this is the first prototype that I assembled. Okay, so as we can see, the black foam is where we will place the fruits, and the center of the foam that will be hole, and I place the mini actuator and the microphone sensor there. Okay, so the foam will act as a sound barrier to ensure there are no outside sound that will interfere with the data I collect. And the collected data will be shown in the LCD display. And now we will go to software development, and the programming language that I use for this device is Tony Python IDE. Okay, this is the most suitable for me. Okay, so now we go to the system development, and this is for the testing and evaluating the fruit sample. So the number of sample that I use is 100. Okay, how do I test the sample? Is that I put the fruit, the top segment of the fruit, to the microphone sensor and press the start button to start the hammering process. And I will take the top segment reading 3 times and the bottom segment reading 3 times. We will get the average, and the difference between the average will determine whether the fruit contain any IFR or do not contain any IFR disease. Okay, that is the flow of the device during the testing session. Okay, so now we go to the result and discussions, and in the slide is shown the last version of this device. So we improve the span a little bit to improve the sound cancellation and the sound barrier to ensure no outside sound can interfere with the data. Okay, now we go to the user interface that I create. Okay, this is the display that we shown in the LCD screen. Okay, in the screen there are bottom acquisition, top acquisition, and analyze data. Okay, when we place the top segment of the fruit on the white span, okay, we will press the top acquisition on the screen, and the device will give a gentle tap to the fruit, and the frequency will be recorded, the sound frequency will be recorded through the microphone sensor, and the data will be sent to the microprocessor, and we will repeat the procedure using bottom segment of the fruit, and we will press the bottom acquisition. Okay, after finish both side of the fruit, okay, we will press the analyze data, and the algorithm will analyze, the microprocessor will analyze, and the result will show whether the fruit contain IFR disease or do not contain IFR disease. Okay, in the slide, I insert 5 of the 100 sample that I used to determine the IFR. Okay, as we can see, there are top segment and bottom segment. I take 3 times to get the top average and the bottom average, and the difference between top and bottom average will determine whether the fruit contain any IFR or do not contain any IFR. Okay, as we can see in the scatter plot beside, there are a level that distinguish between a harum manis mango that contain IFR and do not contain IFR, and I stimulate and I test through MATLAB and the specific level is 1008. 1008 is the average reading difference that will determine either the harmonious mango contain any breakdown tissue or not. And the result get from the device is cross-checked with the original fruit. We will cut down and see and compare the result from both sides. Okay, this is the result that I get from simulating the data that I get using ANN, artificial neural network, and KNN, that is K nearest neighbor. So all of the data I get, I place in the MATLAB and I check the accuracy. Okay, so for the accuracy of artificial neural network is 99, and the accuracy classification for KNN, K nearest neighbor, is at 96%. As the artificial neural network has higher accuracy, so I will use this ANN as the algorithm that will determine whether the fruit contain any disease or not. Okay, as the conclusion, the acoustic impulse response method, which involving sound feedback, yes, it can be used to determine the presence of IFR inside the mango fruits. So all of the objective of this research paper has been met. Okay, so the device that I developed with my co-researcher is suitable to detect the presence of IFR. So it is highly accurate and does not harm or destroy the fruit. Okay, so now that is the end of my presentation. We go to questionnaire sessions. If there are any questions, you are welcome to ask me anything. Okay.